the electrodes, does anyone remember the second role of electrodes in fuel cells? Fung? Act as a catalyst. Very good. Act as a catalyst. That's really important. These two, like, literally just memorize them. So then you can regurgitate it on a piece of paper. Okay, so let's talk about a particular example. Are you guys done with this? Yes? Maybe. Okay, so let's talk about a particular example. I'm going to give you guys the full equation, and then I want you to tell me what the half equations are going to be. Okay, so a fuel cell might look like this in a VCAR exam. They will then tell you what they're putting in and what they're taking out, okay? So they might tell you that, I'm trying to think, oxidation. Okay, they might tell you that it's a methane fuel cell. So that arrow pointing in tells you that it's a reactant, okay? And then they might tell you that coming out of this side, we have CO2. Okay, then they might tell you that we have oxygen going in this way, and coming out of here we have H2O. Now, can you guys use oxidation numbers to tell me if I've correctly identified this as the anode? Yeah. I have? Yep. So what's the oxidation number, Kiralee, of carbon in methane? Yeah. Don't worry, don't stress. Talk yourself through it. What's the oxidation number? How would you work this out?
Well, I was going to do start with H, but that changes, doesn't it?
No, that's good.
Oh, because
carbon's sort of in the middle, so that's more likely to change than H. So it would be?
So I'll say that H was positive 4.
H is not positive 4.
I know, yeah, so because
it's positive 1. Yeah, but because you've got 4 of them, is that what you mean? The total is plus 4?
Yeah.
Yeah?
Right, yeah.
Oh, okay, yeah. But you know if you had to tell people the oxidation number of H?
Yeah.
Okay, good. So what's carbon? Yep, negative 4, very good. So carbon's negative 4 here. CO2, what's the oxidation number of carbon there, Isaac? Positive 4, very good. Okay, because we know that oxygen's minus 2, giving negative 4, giving carbon positive 4. Happy with that? So it does show oxidation. Fung, how many electrons have been lost? 8 electrons. Let's see in our balanced half equation at the anode. So the anode in this case is negative or positive, Eleanor? Is the anode negative or positive? Tell me its polarity.
I don't know.
You don't know? Are we working with a galvanic cell? Is it giving us electrical energy, or is it using electrical energy to make chemicals?
Is it negative?
Yes, very good. So it's regular galvanic. When will you ever have in a battery, when will be the only case that the anode is positive? Excellent. A secondary cell when it's recharging. So the anode always where oxidation occurs. And then, what's one thing that I need to know that I haven't told you guys?
Is it in a basic environment?
Okay, so I'm going to tell you that this is an acid fuel cell. I want you guys to provide me the anode and cathode reactions. So cathode is where reduction occurs. Okay, so we start off with methane. It's in the gaseous state. Carbon dioxide in the gaseous state. We're using a fuel cell, everything's in the gaseous state. Then, what do? How do I balance in an acidic environment? Okay, so you guys do that. Add your water, add your H's, add your your electrons. Let's see if we get that loss of 8 electrons.
Wait.
What acidic environment is it in? Isn't this the basic?
But if it said a basic fuel cell, once you get to the H plus stage, add OH to both sides, then the H plus and OH turns into water. Yeah. Guys, good?
Isn't that stuff basic?
Sorry?
Isn't that stuff basic environment stuff?
Which
Like
one?
the balance with OHs and the H's.
This says acid fuel cell.
Yeah, doesn't that mean you just bounce with the electrons?
What? Sorry, go again.
I'm confused, like, because isn't that using the OHs and H's to balance, isn't that a basic environment?
Yeah, so this is just balancing with H plus instead of OH minus.
Yeah.
Just your regular way. Right?
I'm still confused. Is it in like the data book?
Yeah.
It's just like passing electrons.
But it's got oxygen on that side and hydrogen on that side. How are you going to balance for that? First step, Kiralee. First step. Balance for what?
Carbon,
Okay, that's balanced. Second step.
hydrogen,
No.
oxygen.
Yes. How do you balance for oxygen?
Put 2 oxygens on the side.
How can you just put 2 oxygens?
Add oxygen.
No. Guys, how do we balance for oxygen? Water. Do you remember the steps? First step. Balance for everything except for H and O. Truly, I'd write this down. Balance for everything except for H and O. Step 2. Balance for O by adding H2O. Step 3. Balance for H by adding H plus. So Kiralee, this is the acidic environment. This is the way we balance in an acidic environment. This is where you would sort of stop. You do these steps. And then you balance for electrons. In a basic environment, how does it differ? What other step would I have? Carl, do you remember?
So we add OH after balancing with H2O.
Excellent. Oh no, hang on. No.
Oh no, after H. Yeah.
So add OH to both, add OH, 1 for every H plus, but you have to add the same number to both sides. Do you remember that, Kiralee? You have to add the same number to both sides, but same to both sides. This is like the only difference, okay? Because step 5 is balance for charge by adding electrons.
Hey Carl, you walk to school.
Well,
Stronger.
Very
Pass
rare.
the day, you have nothing to worry about.
Okay, guys, happy with this?
This flip flops.
And then let's go. So, did you get 8 electrons?
Yeah.
Everyone? Okay, so you would have had 2 plus 2 H2O plus 8 H plus.
Is everything gaseous, even the water?
Yeah.
It wouldn't be a gas.
No, because so your inlets are gaseous. It really depends on what it says in the question, because if they do it at room temperature, it's an indirect combustion reaction. So the water you produce will depend on what temperature it is. So if it's at 25 degrees, the water has to be liquid. Do you get what I'm saying?
Yeah.
But sometimes they say, like they said the other fuel cell, there was like actually a question that I'll show you later. It's held at 190 degrees Celsius, and you have to know that water's going to be gaseous at that state.
Okay.
But unless they tell you, just assume room temperature, so water's liquid. But the reactants are gaseous.
Yeah. So, is there water all inside the cell?
Yeah.
Or water.
Yeah, what the electrolytes in.
So is there water in the outlets or the tubes outside the electrodes as well?
Yeah, water's free to go around wherever because everything's dissolved in water. Okay, so the cathode one, guys, did we have O2 gas plus 4H plus, I just know this reaction now, plus 4 electrons produces H2O, 2H2O. Do we have that?
Yeah.
Yes or no? Good. Okay, so importantly, give me a full equation. Give me a full equation. What would I have to do? Could I just add the two together?
Times the bottom by 2.
The bottom one by 2. So if I times this by 2, I put a 2 there, change that to an 8, change that to an 8, change that to a 4. What crosses out?
H2O.
H
Okay.
plus.
Excellent. The H plus crosses out, the electrons cross out, and some water. So we get 2O2 plus CH4 produces 2H2O plus CO2. What's this, guys? That's a combustion reaction, but how does it differ? It differs in a very important way. Liquid water. And that's because it's an indirect combustion reaction. We're not raising it to 100 degrees unless the question says we're raising it to 100 degrees. Happy with that, guys? This is your just regular balanced combustion reaction. Should work out the same way. Okay, so fuel cells. There is a disadvantage of primary and secondary cells that fuel cells overcomes. What is it? Sorry? They reach equilibrium, very good, they die. And secondary cells allow us to recharge them, but fuel cells, we get a continuous supply of electricity. So for example, your Apollo space station, you want a continuous supply of electricity. It's the space shuttle. You don't want it to just stop halfway and you have to recharge it. We die, okay? So the disadvantages of primary and secondary cells is that they contain only a small amount of reactants, meaning that they reach equilibrium, the cell is discharged, or it can be recharged. Fuel cells allow for the addition of reactants continuously, allowing constant production of electrical energy. Okay, one thing that I did want to talk about, if you guys are done with these reactions, yes. One thing that I did want to talk about is getting electrical energy from burning coal or burning other fossil fuels. Yeah? Remember in a sort of, let's just say a coal-fired power station. So a coal-fired power station. Do you remember what the energy transformations are? Chemical. So we burn the coal, then heat. Because it releases thermal energy, because it's a direct combustion reaction of coal, as opposed to indirect. Then from heat, we boil water, which spins a turbine, so that's kinetic energy. And then, finally, electrical. Each of these steps has a loss of energy. It's not 100% efficient. Not 100% efficient. If only 20% of this is going into that, your efficiency is going to be well below 20%. Like, it's limited by the least efficient step. Does that make sense? Okay, whereas with a fuel cell, why is a fuel cell so much more efficient?
Because you use all this stuff. It's one step.
Excellent. And guys, when you are producing heat energy to spin a turbine, We know the effects of heat loss from calorimetry, yeah? They can be very grave. So if you're losing a lot of heat energy, okay, I would say most of the energy would be lost in this step when you, and it would be radiated as heat. You'd lose a lot of your heat energy. It wouldn't go all to heating up the water, okay? We're not getting that step. We don't create any heat energy. Direct conversion. So more efficient direct conversion. You would just say less energy conversions. Conversions equals more efficient. Are you guys happy with that? Cool. I think I wanted you to do also, okay, I want you to tell me, using your data book, we'll just go to, oh, and they're not rechargeable for obvious reasons. They're just continuous supply of reactants. Okay, so I want you guys to have a look at this. We've done methane. We've done this one. Okay. But I want you guys to tell me what in the hydrogen-oxygen fuel cell, in a basic environment, what would the cathode and anode reactions be? Cathode and anode.
Can you be pretty confident that if it's like something oxygen, that the oxygen is the oxidizing agent?
Yes, very good. Yep. But also, they're all indirect combustion reactions, yeah? So you all know how to write out combustion reactions. So even if it's hydrogen plus oxygen, when that combusts, what do we get? Obviously not carbon dioxide, but we get water. So
is every sort of product ever in these reactions usually water?
yeah, there is water. Carbon dioxide as well, like with the methane one.
So when it just says methanol oxygen cell, how do you know what's actually coming out?
It's always an indirect combustion reaction, or they'll give you a picture of it and they'll show you the output.
Oh,
So once we do questions, it's going to become really apparent. But in this case, guys, you're going to have your overall equation, which is like this. These you can take, don't waste your time writing them out. You can get them directly from your data book. The hydrogen and oxygen ones are in your data book. The methane ones aren't. And it's direct copy if you know how to use your data book. Let's show you what I mean. Okay, here's our data book. Here's our electrochemical series. Guys, what is the oxygen reaction, half reaction, in a basic environment? Can you guys spot it? Oxygen half reaction in a basic environment. Can you tell me by E in volt? 0.4? Very good. Notice when they've balanced, what they've done is they've grabbed the, well, first VCAR really wants you to be able to use your data book, but let's say that you were to have to balance it. The oxygen, you guys try to do it. Using this in a basic environment, how would you balance for the anode and the cathode? What's the way we could determine what's at the anode? Oxidation numbers. So use oxidation numbers in a basic environment. See if you get the exact same equation. So what's the oxidation number of hydrogen? 0. And oxygen? Hydrogen? And oxygen? -2. So oxygen's being reduced. Will that occur at the cathode or the anode? Reduction? cathode, and hydrogen will be oxidized at the anode. So just do it like regular. Let's see how we go, yeah?
How can we assume that that's the reaction that's going to happen, sort of indirectly? Like, you know, like,
It's a combustion reaction. You always get water and carbon dioxide, but if you don't have carbon, you just get water.
so when it says hydrogen, oxygen, fuel cell, you just know it's going to be that reaction.
Yeah. Plus we've gone through that reaction. Okay, I'm going to write it out as well. Okay, have you guys finished or not? How are we going? Okay, so you found them, but did you get the same one if you just did it? So, like, you can always use your first principles if you're too scared to use the data book, or you could directly copy it from the data book. Okay, so first thing, oxidation numbers. The thing being oxidized is H, yeah? So, and I should get 1 electron lost per H. So, you can actually write it out like that, H2 to H2O. Yeah, this just will waste a lot of time in your exam because we balance for everything except for H and O, well there's nothing else. Then you balance for O by adding water, so if you add H2O, then you balance for H by adding H+, so you add 2H+. Then you balance for, it's in a basic environment, so you balance for H by adding 2 OHs to each side. Okay, then you start cancelling. Like we've got a lot of things we can cancel. That 2H and 2OH makes what? 2 waters. So 2H2O, that H2O plus 2H2O will make 3H2O.
Get rid of one of the H2Os.
Yep, so we'll just go step by step, plus H2, oops,
Why do we have 2 OHs?
and we've got 2 OHs on that side. Then we cross that out and this makes 2 waters. So it ends up being plus 2 electrons. And where's that on your data book, in your data book? Minus 0.83, yeah? That is the half reaction that occurs at the anode. It's obviously not that directly, but it's that backwards. You remember that fuel cells are working on spontaneous reactions, yeah? So it's this reacting with, which one is it? This. By a negative gradient. Are you guys happy with that? Now, you know, if worse comes to worse and you like don't know how to use your data book, you can do it like that. It just takes a while. But can we just get a quick show of hands, like who actually understood that, where we got that equation from? Okay, cool. And then you could do your cathode one in the same way, or you could get it from your data book in a basic environment. Now, can you guys tell me how to work out the maximum cell voltage for this basic H2 and O2 fuel cell? Top minus the bottom, so 0.4 minus negative 0.83, what's that? 1.23 volts. Okay, now, Isaac, did you want to have a go at telling me what the two reactions would be if it was this reaction, so H2 and O2 again, but in an acidic environment?
Would be
So yeah, take the time.
plus 0.68.
Plus 0.68, which one? But it's producing hydrogen peroxide. Remember that our only product is water.
I'm not sure.
What's another possibility? Keep looking. You're doing the right thing by looking at where oxygen is in an acidic environment, but you've missed one. I think I've got something covering it too.
Oh,
Plus 0.4.
no.
That's in a basic environment. 1.23 this one.
Yeah.
And what would be, so that would be at the cathode or the anode? Is it undergoing reduction or oxidation?
Reduction.
Yeah, which occurs at the, excellent. Okay, and what would be our anode half reaction? The other one would have to be H2 reacting. You guys.
Yeah, it's crazy.
So
0, very good. So this one. And what's the maximum cell voltage? 1.23 volts again. So it doesn't matter if you've got it in an acidic or a basic environment, you're going to get the same voltage. And you get the exact same reaction. Only water produced. So that's a good thing, right? Environmentally. So do you guys get how to get those reactions now from your data book? This is the acidic one. That's the, oh no, this is the basic one. This is the acidic one. Yeah? Yep.
Is it hard to collect the reactants for these fuel cells?
It's very difficult to transport gaseous reactants. Yes. Yes. That's one of the problems. That's what we're going to head into, but I'm just going to make sure. Okay. We're going on to question time now, but, okay. Let me grab,
Can I ask a question about the electrochemical series?
yeah?
When you're finding the overall charge of a reaction, and you know how some reactions have to flip depending on whether the cathode or the anode,
Mm-hmm.
do you change the sign?
No, by doing that minus that, you've already changed the sign.
Wait a minute, hang on. Are you minusing it though? If you had, for instance, if you had 0.4 and then below it 0.2
It's still minus.
plus,
So what you've done is you've already changed the sign
that's
by
the-
making it negative
if it's
0.2,
minus it would be negative negative.
and we'll change it to a positive.
So
Yes.
when the equation flips, so does the voltage.
Yes, but you don't flip it. You just do top minus the bottom, and it does it automatically.
I feel writing
In-
it would be flipped though, wouldn't it?
No, you just do top minus the bottom. That's all you have to do. Don't overcomplicate it. In
Okay.
uni, we learn it like this. The top stays the same. The bottom has to be flipped, and you add them together. But it actually doesn't make a difference. Top minus the bottom,
Yeah.
or top plus the bottom flipped.
But
It's
as
just
soon as you
making
flip it,
life
the
a bit
sign
easier.
changes. So that's why you can add them. Because the sign changes.
Because the sign shape,
Okay.
yeah. But you just do top minus the bottom and it does it for you. Okay, so just before we go into question time, can you guys write out the anode and cathode reaction, because I just want to make sure you got it. The anode and cathode reaction for methanol oxygen fuel cell in a potassium hydroxide electrolyte. I would start with writing out the full equation, seeing what's oxidized, what's reduced. You may just already know because you know that oxygen, blah, blah, blah. But I would start by writing the full. I want you to write the anode and the cathode reaction just for this one. Methanol oxygen. Are you going to do methanol oxygen?
Yeah.
Yeah?
Miss, can you know up?
Yep.
I still have something that is getting it.
Okay. So what would you get as products? Yeah, very good. So which one's oxidized? Which is reduced? Yeah. Hang on, that's not plus 3, that's plus 1. That's oxidation. I've got sort of total of plus 3. Yeah, always make sure you do that. So plus 3 minus 2, yep. Isn't this plus 3 minus 2 would be plus 1? Wouldn't it be plus 2, so wouldn't that be minus 2? That would be plus 2, so that would be minus 2. That's alright, don't worry.
So is that the full reaction?
What's wrong?
Didn't we just write this before?
No, we did
We did methane.
methane. Carl, get more times. No, I'm just kidding.
This one,
Yes,
how would we actually find the reaction?
it's always combustion.
Okay.
Yeah.
But not before.
It was combustion before.
But if we have yeah, it was just oxygen, hydrogen. Wait, no.
Which one are you saying was it?
This one, hydrogen, oxygen is water.
That's combustion.
Is it?
It's just because it doesn't have carbon, so you
Yeah.
can't make carbon dioxide. That's the
Okay.
only case that you'll only get water. Yeah.
All right. And so with this one, is it
Yeah.
okay to assume that it'd just look like that?
Yeah, perfect.
Okay.
I'd even balance so that later when you do your half equations, you can see if they add up to that.
And so that's the full equation then.
That's the full equation. Yep. But balanced. That's not balanced yet. But yeah, so your water will be liquid, I think. It depends on the temperature that they have the fuel cell at. Okay, good. Two there, but 4 there, so you'll put 2. No. You're just balancing a combustion reaction, yeah? So all you can only put numbers at the front. You're not doing your half equations now. The half equations are after you've identified your, so you've got to put a 2 there. Purely, this is your full equation. When you do your half redox equations,
Yeah.
that's when you balance with H plus and
Okay.
H2O. But that's right, you put it in there.
Is it in a
Because I think there's 4 H's on that side, now there's 4 on that side. How many oxygens? 1, 2, 3, 4, that's 5 on that side. 2, 3 on this, 4 on that side. So that shouldn't be a 2, that should be a 1.5. And then you can change change it to 2, 3, 4, 2. You left a couple in there, did you? Okay. So methanol, CH3OH. Plus oxygen produces H2O plus CO2. Really depends on the temperature. That's the annoying part about all of this. Look, but if you balance, you guys should have had 3, 2. Is this 2?
Yeah.
And
oh, wait,
4?
that's 4. I
That's
have
four.
the other way around.
4, 2. Okay, so with your half equations, we are in a basic environment, which makes life less fun. Very good. Good start. It's a little airborne. No. I love The Simpsons. I just say it in the weirdest time. All right. So, do we have at the anode, do we have the oxidation of methanol? Yeah? To carbon dioxide. And at the cathode, we should have the reduction of oxygen to water. Yeah? Is that what you guys did? Okay, cool. So let's start balancing. Same number of C's on each side, tick. Then we've got how many H's? 4. So 4, oh no, gotta go water first. So plus 1 water. Yeah. And then plus 4, 5, 6 H's. Okay, now we go OH to either side, so 6 OH to that side and 6 OH to that side. So then that changes into 6 waters. Yeah? But first, can we remove some water?
Yep.
Is that right? Have we done it right so far? 5.
Yeah, that's
That's why
Can
I
we go
remove
up?
1 water, make it only 5 times.
Oh, okay. So remove 1 water, make it 5 waters, and then 6 electrons to that side?
Yeah.
Cool. Okay. Plus 6 OH negative produces that. Plus 5 H2O plus 6 electrons. Okay, now Emily, I know you worked out the oxidation numbers. What was the oxidation number of carbon?
-2,
And what was it on this side?
+4.
How many electrons has it lost to go to plus 4 from a minus 2?
-6.
Yep, and is that represented in the equation? Yep, always works. Yeah? Okay, now the cathode. Okay, so we balance for everything except for H&O, then we balance for oxygen by adding water, so you can put a 2 there. Did you guys do that, or did you add another water? And then H's by adding 4H plus. Then we go up, we're in a basic environment, 4OH minus to either side. And this should turn into 4 waters. 4 waters, and I've got 2 on that side, so how many on this side? 2 waters. Is that right? And 4 electrons. Yay or nay?
Yeah.
Yeah? Okay, now, let's see if it matches our full equation. Okay, it's going to be hard, I understand. What would I have to do to my electrons to make them equal? Like, what would I have to do to each half equation?
Times the top one by 2 and the bottom one by 3.
Very good. Times it by 2, times this by 3. Okay, you guys do it as well. So 2, 12, and 2, and 10, and 12, 3, and 6, and 12, and 12. And you might see something a little nice at this stage. Starting to all come together. Even though it's an ugly equation, yeah? What cancels out?
All your OHs and all
All of
your electrons.
And some water.
your electrons and some water. And we end up having 4 waters on this side, plus 2 carbon dioxide, and then on the other side, perfect balancing. Yeah? Guys, was this oxygen equation in your data book?
Yes.
Yeah? Did you all see that? Which one was it? In basic environment, the oxygen reaction was this one. So your oxygen one's there, your methane and methanol and stuff aren't there. Happy with that? Okay, so let's go back to the slides. Let's answer some questions. Okay, first one. We're going to go kind of drilling because we don't want to be here all night. Unless you want to. But anyway, question 18. Let's go. Everyone write an option down. After you wrote it. Before you've read it. Thanks for humouring me, Shirley.
Here's your blank.
I'm getting better at teaching. I don't have to use my notes. Memorised it all. Which of these are incorrect? So which things are correct? A, B, C? What's wrong with D?
Fuel cell.
A primary cell? Gemma, what's a primary cell?
A primary cell isn't just a galvanic cell.
Yeah,
It can't
that
recharge,
you can't recharge it.
so that's wrong.
Yeah, so all of your reactants are kept inside your cell, then it's discharged, throw it away. That's your alkaline cells. Huh?
You can't recharge your fuel cell either.
Yeah, but the reactants aren't kept inside the cell. Remember, there's 3 types of batteries: primary cell, secondary cell, fuel cell. Definite different
So
one.
how does it count as rechargeable then?
It doesn't count as rechargeable.
Oh,
It just means that
sorry, it's not rechargeable. Yeah.
Just doesn't do it.
it's just a continuous supply of reactants, as opposed to, imagine having your little zinc battery, or like whatever you put into your remote control, tiny like reactants being flowed into it. That's just not going to happen. So, okay, so from that, I'm assuming that you don't remember.
Oh, God damn it.
Oh,
That's it.
I'm assuming that you may not remember your advantages and disadvantages. Why didn't you go through this table? Advantages of fuel cells. They convert chemical energy directly to electrical energy. We know that one. Water is a byproduct. Well, not in all cases, but usually, like the oxygen, hydrogen one, the one that they play on a lot, you just get water. It definitely reduces the amount of CO2. When you've got something more efficient, yeah, you're using less reactants to make the same amount of energy. Can you guys appreciate that? Yeah? So it definitely produces less waste, doesn't reach equilibrium, we get a continuous supply of electricity, use a variety of fuels, we learnt that, Electricity can be generated on site. Generate little noise. You could put it under your coffee table. This fuel cell.
It's great, Gemma.
Huh? Yes.
Is it noisy? Is it like?
It was like one of the options. Disadvantages. Guys, the effectiveness of some fuel cells are lowered by impurities in hydrogen fuel. The use of fuel cells in transport is limited. Guys, you are transporting gases here. It's really difficult to do that. You need to compress the gas. It can be dangerous. Hydrogen gas, yada yada. Requires a constant supply of energy, so they're expensive. Limited numbers, and they generate a direct current. If you want to use that one, if you're in physics, probably you more know about it. But I just got these all from the VCA questions. Okay, so let's go back. Let's go to this question now.
What was the direct current?
Sorry?
What was the direct current?
Yeah, fuel cells generate a direct current. Electrical appliances require alternating current. Therefore, you would require an inverter to change from a direct. You just need something extra to be able to make it usable for us. No, that's never been in VCA. This was from me. And it was just in the answers. It wasn't even like part of the question. If you see that, show me that. I don't think so. Okay, so guys, we're going to plow through these. Grab your data book out. These ones, the first three questions are not fuel cell questions. They're the electrolysis ones that we did in the last week of school, but I want to see if you remember them. Okay, so get out your data book. I'm going to give you 3 timed minutes to answer these 3 questions. 3 minutes. Time starts now. Nothing up there. Which one? It's the same as the data book. That's like 10 more. Yep. Okay. Guys, write down options, yeah? Guys, are you focusing as well? An aqueous solution. Come on, guys, we've got to get through this. Guys, write your. You really know how to do this, guys. Question 18 is okay. If not your oxidants, your reductants, pick your strongest oxidant that will be reduced. Do you remember that? Oh, I've got said oil. I get it. maybe just list.
See,
Sorry. No. Like when you look at an aqueous solution containing that and that, what things do you have? Can you just list out what things we've got present? Yeah, so we have potassium, which is A+. Yeah, so just list them out first. That would be the first thing. Yeah. But wait, does that have a charge? Yeah, so whenever you've got a metal and a non-metal, that's an ionic compound, so they separate into one positive and one negative. Yeah. And what's the other ones that we've got present? Very good. And what else do we have present? Excellent. Yeah. So oxidants, do it like the same as what's in the electrician. Do you guys want the aircon on?
No.
No?
She's like, we do.
Yes, I do.
Yes. So hot. Are you kidding me? Quick vote.
Yes.
Yes, please.
I'm indifferent.
It's like a cool.
You freaking liar.
How about the fans?
This is nothing.
Okay, are we finished, guys? Yeah? Okay. Guys, these should only take you 2 minutes each. Or 1 minute
How long are we
each.
meant to stay on multiple choice?
Sorry?
How long are we meant to stay on multiple
Like a
choice?
minute each.
Nah, they don't give you a minute per mark in counting. They give you quite, so I think it, like in the 90, they give you in the 90-minute exam, they have like 70 marks. So I don't know what percentage. Okay. So guys, how are you going? Very good. Excellent. I can't answer anything. No, that means you have to overcome that. You don't want to go into the exam thinking that. Yeah.
But some of them might be really quick, like some of them might take you 10 seconds.
Guys, are you gonna-
Why does this it's like 4 different things, like one mark.
What did you get, guys?
C, D, D.
So did we get electrolytic cells? Anode is positive. Cathode is negative. Did we get B?
Yes.
No,
Okay, for the next one, guys, what did you have to do? Kira Lee, can you tell me what you did?
I found where they were on the data chart thing.
Yeah.
And you have to know that it's aqueous and water's involved.
Very
And
good.
Because it's an electrolytic cell, it can be in a positive gradient. So,
Good. Keep going. You're making me very proud.
and then you have to do the line thing.
All right, now we stop. No, just keep going.
And so you the strongest oxidant and the strongest reductant. You
Very
line them up.
good.
And the higher up on the oxidant side, and then lower down. You do a line.
Very good. So what did you get?
D.
Oh, beautiful job. Okay, so guys, did you guys get D as well? For the second question? What did you get? Yeah, so why are you guys here if you're just going to chat? Are you? All right, tell me what your steps were. So you wrote that down.
Yeah.
You did that well. Then, what would you have done?
Drawing out that graph or table,
Yeah?
and then
How can you tell which is preferentially oxidized?
Which is position on the electrochemical series.
Higher up or lower down?
Preferentially oxidized, so,
Oh, sorry, the preferentially oxidized. Yeah.
higher on the right. Yeah.
Hang on. What are the things? They're oxidants, so they would be, yeah. So they're all written in reduction reactions, right?
Oh, lower.
Yeah, yeah, I know. It's a bit confusing, but I got confused there. Okay, so which of these are oxidants? We should have H2O, and yeah, and is no, that's a reductant.
Yeah.
Yeah. Okay, so is water the highest?
Yes.
Yeah. Not that you have to do this in this case, but like if you were, is it like this? Yeah. And then on the other side, which order? H2O. We don't have chloride. Iodide is lower. And where's bromide? Okay, so which one's going to be oxidized at the anode? Very good. So it's D. Are you guys happy with that? Yeah? Okay, how about 20, guys? Lithium metal is manufactured by the electrolysis of lithium salts. Which of the following would be used as the anode and the electrolyte? So what do we have to keep in mind there?
Industrial.
Sorry?
It's industrial.
Yes? What else?
Whether or not water
Whether or not water will compete.
And whether or not iron will react at the anode.
Very good. Whether or not iron will react at the anode. Now, if you're doing lithium chloride, it's the same as sodium chloride in a way, the one that we did. You want chloride to react and you want lithium to react. That's what you want. You want to get chlorine gas. It's expensive. You don't want your electrodes to decay over time. That's the one thing you want. You want your electrodes to be unreactive, inert, so you get your cell for as long as possible. Okay, so out of lithium and chloride, which one's the oxidant? Lithium, and the reductant's chloride. And where does water sit in terms of?
Above lithium.
Okay, so water will compete both times. So what do we need to use? Molten. Now, you'd want to use a solution over molten. Why would you want to? Like, it's cheaper. Yep. What else? Safer, won't wreck your system, won't wreck your electrodes. Over time, it gets stuck. The molten stuff solidifies on it. So we would love to use it, but we will just be turning water into hydrogen gas and oxygen gas, so it's not really a profitable process. So we use molten. Now, let's see where iron sits. No, so it's either that or that. That's what I meant. Either this or this. So carbon and iron. So carbon, is that on the electrochemical series? No. So we have to look at iron. Where does iron sit? Fe solid.
It's above water.
I'm below water.
Oh, you mean the other water?
Yeah, I'm right.
So in other words, it will be preferentially oxidized. It's a reductant.
Yeah.
But it will be preferentially oxidized. That means what will happen to your anode over time if you use iron as your anode?
You're actually getting both with the
And also, do we want our anode to corrode over time? Just use logic, otherwise your cell stops. So you've got to use, which one? D? Okay, let's see how VCAR went. 86% for the first one. That was easy though. That was like the polarity charges. 54% could tell that it was iodide. And 61% chose solid. Lithium molten. Okay, how about this one we've done in class? I'm just trying to think of more fuel cells sort of stuff. No, that's also stuff like this. Is this fuel cell? And that shows, so guys, this is the type of chemistry questions that you'll get. Methanol is suitable in a fuel cell. The half equation for the anode reaction is this. Do you remember we wrote this out before? Or no?
Yeah.
Was it?
Yeah.
Similar. And then it says write a half equation for the cathode. What would you do?
Because-
Cathode would be,
Because it tells us that lead makes carbon dioxide and water, do you assume it's with oxygen, or does it say something else?
yeah, it's always with oxygen because it says methanol is oxidized to carbon dioxide and water. It's always in a fuel cell, it's always a combustion reaction.
So that's just
It would have to be
a
O2 plus 2H2O.
O2
Plus 2H2O.
plus 2H2O.
Plus 4 electrons. Oh wait, hang on.
No,
Wait,
that's
is
the basic one.
this is basic.
How can it tell us that it's in an acidic environment? How does it tell us, Kiralee?
It's OH.
Where's the OH? But acidic is H+, not OH. Basic is OH. Where does it tell us in the half equation that it's in an acidic environment? What have they balanced with? H+. That tells you guys. Guys, you really have to know that. H+ equals acidic environment. OH minus equals basic environment.
Yeah, so sorry, get rid of that water.
Oh, so it's not that one? What is
Yeah,
it?
No, that's all right.
Yeah.
The electrons are fine. Plus 4 electrons
Yeah?
equals 2 waters and 4 H plus. I think. Oh no, sorry. Don't listen to me.
O2 plus 4H plus 4 electrons makes 2H2O.
2H.
4H plus needs
Ah,
to be on
okay.
both sides.
Yeah. Okay. All right. How about this one? A finely divided catalyst is used in this cell. Give a reason why it's important to have a catalyst that will significantly reduce the activation energy. It tells you at the top what it's used for.
Hey, is this 2011?
Maybe. It's used to power laptop computers and small electrical items. Why do you think we might need to use a catalyst?
Reaction.
We need a fast reaction.
Does that work spontaneously? Like it won't just spontaneously combust?
Yeah, it will. It'll just take a long time to do it. So we're just speeding up the reaction. Spontaneous just says negative gradient, yeah? It's nothing about rate. Why would we need a high rate of reaction? Have a look at the use. No? Not to do with voltage?
Just to use the laptop?
To use the laptop, guys. Do you want your laptop to be slow or do you want it to be fast? Okay. So to be able to get a constant power, do you want your laptop to be constantly turning off and on?
Yes.
Okay, the state went shocking in that one. 46% got it, this one, the equation, and then 17% got that question. Okay. So, guys, a fast rate of reaction is necessary for efficient current flow / instantaneous current of the computer. Since the computer is being
How do they
used...
know that? First of all.
Well, you wouldn't melt your computer, but since it's being used at room temperature, catalyst will increase the rate of reaction to an acceptable level. Guys, you know that fuel cells work on indirect combustion, yeah? You have to know that they would be slow because they have combustion reactions have high activation energies. Yes? So if they have a high activation energy, we need either a spark, we don't want a direct combustion, so we need a catalyst. Always, so that's why we have those electrodes used as catalysts. Can you see that? Not really? Really? Okay, guys, we'll just do a couple more and then we'll go. So let's work really hard on these ones. I'm going to give you time to do them.
Just do electrochemical processes summarised in the diagram.
Yeah, it just says a Victorian company produces solid oxide fuel cells for use in the home. The fuel cell used natural gas to produce electricity through this process. process.
Yes.
So first one, easy question.